here we're going to look at some applications of rational equations. So we'll start out with some work examples, and that's where you have two entities working on something. And so here we have, it says a mason can construct a wall in 18 hours. His apprentice can do the job in 27 hours. How long would it take them to construct the wall working together? So let's let X be the time it takes them to complete the one job working together, and the one's important here. I'm going to set up a table. So since they're going to work together till the job is done, they're going to work the same amount of time, so they're both going to work X hours. So Mason and the apprentice both have the time. Now, if the mason can do the job in 18 hours, then the rate the mason works is 1 over 18, because he does 1/18 of the job per hour. So the portion that he's going to complete, the portion of the wall he completes, is actually X times the rate. So X times 1 over 18. And that's just going to be X over 18. And then the apprentice works at a rate of 1/27th. So he can do 1/27th of the job per hour. So the portion he completes is X times 1/27, or X over 27. Now, we're going to add the two portions together, because if we add the two portions together, that should equal 1 for one job. So this is the portion of the job done by the mason. This is the portion of the job done by the apprentice. Add them together, that should equal one whole job. Now, to finish solving this, I need the lowest common denominator, and so 18 and 27 will both go into 54. So if I multiply X over 18 by 54, then I know if I divide 18 into 54, I get 3. So X times 3 would give me 3x I mean. And then if I multiply X over 27 by 54, I know 27 goes into 54 twice. So that's going to give me 2 times X. And then, of course, if you multiply 1 by 54, you get 54. So then I can add these together, and I get 5x equals 54. And then if you divide both sides by 5, you get 54 over 5. And then if you grab a calculator, you'll see that that's 10.8 hours. Okay, so, or 10 hours and 8/10 of another hour. And if you needed that in minutes, you could just figure out what is 8/10 of an hour. So you'd have 10 hours and 48 minutes, I believe is what that would be. Okay, here's a similar problem. A new printer can print the payroll checks 3 times faster than the older printer. Working together, the old and new printer can print the payroll in 7.5 hours. How long would it take each printer to do the job working alone? Okay, this is similar, but it's looking for something a little bit different than the last one. So here we're going to let X equal the time that it takes the faster printer working alone. And then remember, the time for the slower printer must be much more, right? But we know it's 3 times, since the faster printer is 3 times faster, then the actual time it takes would be, for the slower printer, would have to be 3 times the time for the faster printer. So the time would be 3x for the slower printer working alone. Not alone. But anyway, we know when working together, they can complete the job in 7.5 hours. So we know the faster printer's going to work 7.5 hours. And we know the rate would be 1 over X, because remember, the rate for the faster printer, it can do the job in X hours, so its rate would be 1 over X. And then the portion completed would just be 7.5 times 1 over X. Now the slower printer, it's going to also work 7.5 hours, but its rate is 1 divided by 3x. So if we take 7.5 and multiply it by 1 over 3x, well, that would actually be 3 goes into 7.5 2.5 times. So that would be the same as 2.5 over x if we multiplied those together. So now the portion completed by the faster printer would be 7.5 over x. The portion completed by the slower printer would be 2.5 over x. And if we add these two together, 7.5 over x plus 2.5 over x, they should equal 1. Now, since these have the same denominator, we can just add the numerators. So 7.5 plus 2.5 would give me 10. So that would be 10 over x equals 1. And then if you just multiply both sides by x, you'll actually get 10 equals x. So x is 10 hours. So the faster printer can do the job in 10 hours working alone. And then the slower printer can do the job in 3 times that, so 30 hours working alone. So that would be the solution for that one. Now, you can also do what's called a uniform motion problem, which is basically distance, rate, and time. So let's look at one of those. A commercial jet travels 1,620 miles in the same amount of time that a corporate jet travels 1,260 miles. The rate of the commercial jet is 120 miles per hour faster than the rate of the corporate jet. Find the rate of each jet. Well, let's let R be the rate of the slower jet, so that would be the corporate jet. And then R plus 120 would be the rate of the commercial jet. Now, we know the corporate jet is going to go a distance of 1,260 miles at a rate of R. So the time that the corporate jet's going to travel, would be 1,260 divided by R, because time is distance over rate. Okay, and then for the commercial jet, it's going to travel a distance of 1,620, and its rate's going to be R plus 120. And so the time that it's going to be traveling is the distance over the rate, so 1,620 over R plus 120. Now, we know their times must be the same. So this is the time it takes the corporate jet to make the trip. This is the time it takes the commercial jet to make the trip. And since those times are the same, we can just set those equations equal to one another. Okay, now this is a proportion. And so earlier we learned how we can solve a proportion by cross multiplying. So I'm actually going to just multiply these two together first, 1,620 times R, and I'll get 1,620R. And then I'll multiply these two together, 1,260 times R plus 120, and then distribute the 1,260, and I get 1,260R, and I grabbed the calculator. 1,260 times 120 is 151,200. Okay, then I subtracted this. If you subtract 1,260R from both sides, if you take 1,620R and subtract 1,260R, you get 360R equals 151,200. And then if you'll just divide 360 into both sides, on the left you'll just get R, and on the right you'll get 420. So R is the rate of the corporate jet, so it's actually going to travel at a rate of 420 miles per hour. And then remember, R plus 120 is the rate of the commercial jet, and it's going to travel at a rate of 420 plus 120, which is 540 miles per hour. So there's the solution to this problem. Now I'm going to show you number 2, but I'm going to skip it. So if you want to freeze the video and work through this one, you can. But I'm going to go ahead and go to number 3 next. So freeze the video if you need to. And I'm going to go to number 3. Okay, so here it says traveling with the current. The boat can travel 44 miles in the same time it took to go 28 miles against the current. Find the rate of the current. Okay, so let's let R be the rate of the current. Then its rate with the current would be, let's see. Okay, there was a piece missing to this. You also should have been told that the boat can travel at a rate of 18 miles per hour in still water. So anyway, that's without a current. So now, if we let R be the rate of the current, then the boat's rate with the current would be 18 plus the rate of the current, and then the boat against the current would be 18 minus the rate of the current. Okay? So now, we know the distance it traveled with the current was 44 miles, and we know the rate that it can travel with the current is 18 plus r, where r is the rate of the current, and we know time is distance over rate. So the time, 44, would be 44 over the rate, which is 18 plus r. That's with the current. Now against the current, the distance to travel against the current is 28 miles. The rate against the current is 18 minus the rate of the current, and then that would be for a time of 28 over 18 minus r. Now it says it can do these two trips in the same time, so the time with the current and the time against the current must be equal. So we set these equal, and then we can cross multiply, and so I can take 28 times 18 plus r, and that must equal 44 times 18 minus r. And then once you set that up, you should be able to solve it. Just distribute the 28 through here and you get 504 plus 28r. Distribute the 44 through here and you get 792 minus 44r. And then if you collect all your r's to one side and all your constants to the other side, you'll get 72r equals 288, and then just divide both sides by 72, and you get r equals 4 miles per hour. And so there's your rate of the current. I'm just going to set this one up here, and so a number plus twice its reciprocal is equal to 11/3, and then find the number. So let's let n equal the number, and then so we take the number n plus 2 times its reciprocal, and its reciprocals would be 1 over n, equals 11/3. And now you just multiply everything by 3n, so n times 3n is 3n squared. 2 over n times 3n would give me 6 by itself, and then 11/3 times 3n's, the 3's would cancel and I'd get 11n. And then just move your 11n over to the other side and you'll get 3n squared minus 11n plus 6 equals 0. And then just factor that into 3n minus 2 and n minus 3, and then set those two factors equal to 0, and you get n equals 2/3 or n equals 3. So there's actually two answers for that problem. Now I'll end with a couple of proportion problems. This first one says an investment of 5,000 earns $425 each year. At the same rate, how much money must be invested to earn $765 a year? Well, you know the ratio of 5,000 earns $425. So you need to know how much money X will earn $765. So you just set it up like a proportion. And then you can cross multiply here. 425 times X must equal 5,000 times 765. And so I ended up with 425X on the left. And when you multiply this together, you get 3825000. And then if you divide both sides by 425, you get 9,000. So your answer, you'd need 9,000 at the same rate to earn 765. And the last thing I'm going to end on is I've got similar polygons here. So here I've got a polygon that this side's 9, this side's 12, this side's 15. And over here, the side that corresponds to 9 over here is X. The side that corresponds to 12 over here is Y. And the side that corresponds to 15 over here is 20. So what I can do is I can say, okay, 15 to 9 has to equal the same as 20 to X over here. So 15 over 9 has to be equivalent to 20 over X, since the triangles are similar. And then you can solve that and get by cross multiplying and get X equal 12. And then for Y, you can say 15 must be to 12, so 15 over 12 must equal 20 over Y. And so if you get 15 over 12 equals 20 over Y, and then if you cross multiply, you get 15Y equals 240, then divide by 15, and you get Y equals 16. So that's pretty much it on the rational equations. So we'll see what we got in the next video. The next video I've got coming up is for solving formulas for a particular variable.